Here we have a word problem that's based on linear applications. So the first thing that we want to look at is the information that they give us. The population of a small town in Central Florida has shown a linear decline in the years of 1991 through 2002. So first let's underline some key terms here. Linear, and so you know that's going to be a straight line, and decline, that means that we have a straight line that has a negative slope. It's going down. So second sentence, in 1991, the population was 48,200. So here's our first year and what we started off with population wise. Then the last sentence states in 2002, it was 37,200 people. So you can see that the population decreased. So now in part A, they want us to write a linear equation expressing the population of the town as P. So that means we'll call our function here capital P. Let me use let me go here. And they want us to write this function P as a function of T. So in other words, we plug in values for T, and T stands for the number of years since 1991, so T is time. So we plug in our value for T, and it's going to determine the value of P. In other words, T is the independent variable, and P will be dependent upon whatever T is. And this, to start with, we'll write the rest of the general linear equation. This is in slope-intercept form. So in order to complete this, the right side of this equation, we need the value of a slope, and then we also need a value of B. Okay, so the first thing that we want to do is identify the slope. Okay, and you remember from our general equation, we have the change in y over the change in x, right? Delta y over delta x, but we're not using y and x. We're using P and T. The question is which one goes on top, which one goes on the bottom. Well, y always, in our general equation represents the dependent variable. And in this case, the dependent variable is P, population. And on the bottom is where you put your independent variable. And in this case, the independent variable is T. Okay, so now what is T and P? So let's do this. We need a couple of coordinate points so that way we can come up with the value of the slope. So T comma P. That's what our coordinate points are going to be. And let's see. Let me make this a little bit more legible. T comma capital P. All right. So now the if we, like, the very first criteria that they gave us was in 1991 the population was 48,200 people. So the time that has elapsed, the number of years, remember T stands for the number of years since 1991. In 1991, that value would be 0. Okay? And the amount of people was 48,200 people. Okay. So we have one coordinate point. And then in 2002, that's the time that has elapsed since 1991. That time would be 11. That would be 11 years later. And this time the population, P, would be 37,200 people. Okay. So now we have two values that we can use to determine, or two coordinate points that we can use to calculate the slope. So up here we'll say, 48,200 minus 37,200 on top. That's our change in P, in population. Then on the bottom we have 0 minus 11. And the result of this is 11, this is 11,000 over negative 11, and then this reduces to negative 1,000, which makes sense because if our slope, if we're having a decline, that means that we're going to have a negative value for our slope. Now that I have m, and this will go, this m, this value here is going to go here. Now I need to find out what b is. So if you notice here that this particular value here, this coordinate point, the x value is 0, and then the y value, we have a number there. That's a y-intercept. Okay. Remember, whenever the x coordinate is 0, then you have a y-intercept. So we can use this value for b here. Okay. And because it's it's a linear equation, so it's only crossing the y-axis at one point. So now we can put all this information together and write our linear equation. P of t is going to be equal to, and we have our slope, negative 1,000, right? And actually, I'm sorry, this should be, again, I should have used a t because we're not writing in terms of x, we're writing in terms of t. And so down here I would have t, and then finally I would have plus 48,200. Okay, so this gives us our final equation here, or our linear equation.